My name is Shiva and my roll number is 4H5. I'm from Electronic and Communication Engineering. My topic is response of two-stage RC coupled amplifier in low frequency range with functions. Construction of two-stage RC coupled amplifier. The construction detail of a two-stage RC coupled transistor amplifier circuit are as follows. The two-stage amplifier circuit has two transistors connected in CE configuration, and a common power supply VCC is used. The potential divider network R1 and R2 and the resistor RE form the biasing and stabilization network. The emitter bypass capacitor CE offer a low reactance path to the signal. The resistor RL is used as a load impedance. The input capacitor Cin present at the initial stage of the amplifier couples AC signal to the bias of transistor. The resistor load resistance is used as a load impedance. The input capacitor Cin represent at the initial stage of the amplifier couples AC signal to the bias of the transistor. The capacitor Cc is the coupling capacitor that connects two stage and prevents DC interference between the stages and control the shift of operating point. The figure below shows the circuit diagram of RC coupled amplifier. This is two-stage RC coupled amplifier which was made by two transistor and resistor and capacitors. Operation of RC coupled amplifier. When an AC input signal is applied to the base of first transistor, it gets amplified and appears at the collector load RL, which is then passed through the coupling capacitor Cc to the next stage. This becomes the input of the first next stage whose amplified output gain appears across its collector load. The signal is amplified in stage by stage action. The important point that has to be noted here is that the total gain is less than the product of the gain in individual stages. This is because when a second stage is made to follow the first stage, the effective load resistance of the first stage is reduced due to the shunting effect of the input resistance of the second stage. Hence, in multi-stage amplifier, only the gain of the last stage remains unchanged. As we consider two-stage amplifier, here the output phase is same as input because the phase reversal is done in two times by the two-stage CE configured amplifier circuit. Frequency response of RC coupled amplifier. Frequency response curve is graph that indicate the relationship between voltage gain and function of frequency. The frequency response of RC coupled amplifier as shown in the following graph. Frequency response curve is a graph that indicates the relation between the voltage gain and the function of frequency gain. Here the graph between voltage gain and frequency gain. Bandwidth equal to higher frequency minus lower frequency. We can see the flat response. From the above graph, it can understand that the frequency roll off or decreases for the frequency below 50 Hz and for the frequency 20 kHz, whereas the voltage gain for the range of frequency between 50 Hz and 20 kHz is constant. XC equal to 1 by 2 FC. It means that the capacitive reactance is inversely proportional to the frequency. At low frequency, the capacitive reactance is inversely proportional at the frequency. At low frequency, the reactance is quite high. The reactance of the input capacitor and the coupling capacitor are so high that only small part of the input signal is allowed. The reactance of the emitter by pass capacitor is always very high during low frequency, hence it cannot stunt the emitter resistance effectively. With all these factors, the voltage gain roll off at low frequencies. At high frequencies, again considering the same point, we know that the capacitor reactance is low at high frequencies, so the capacitor behaves as a short circuit at the high frequencies. As a result of this, loading effect to the next stage increases, which reduces the voltage gain. Along with this, as the capacitance of emitter diode decreases, it increases the bias current of the transistor, due to which the current gain reduces. Hence, the voltage gain roll off at high frequencies. At mid frequencies, the voltage gain of the capacitor is maintained constant in this range of frequencies as shown in the figure. If the frequency increases, the reactance of the capacitor decreases, which tends to increase the gain, but the lower capacitance reactive increases loading effect to the next stage, by which the reduction in gain. Due to these two factors, the gain is maintained. At three different stages of frequency, capacitive reactance is capacitive reactance inversely proportional to frequency. When frequency is high, capacitor is short circuited. When frequency is low, then the voltage gain is reduced. When the frequency is medium, reduction in gain. At low frequency, coupling factor high, that only in small part of input signal is allowed. The reactance of the emitter by pass capacitor C is always very high during low frequencies, hence it can be stunt the emitter frequency reactance effectively with all the factors that the voltage gain. This is the construction of two-stage coupled amplifier. Diagram of two-stage RC coupled amplifier. Operation of RC coupled amplifier. Effect of load resistance. Frequency response of RC coupled amplifier. Graph between voltage gain and frequency. Here the voltage gain is constant between two frequencies. This equation shows capacitive reactance is inversely proportional to the frequency. Frequency inversely proportional to the capacitance. At low frequency, capacitance coupling factor is high. At high frequency, capacitor is short circuit. At medium frequency, the gain is maintained constant. Thank you.